Here's a question. Did you know that literally everything on your computer is technically a file? Well, at least if it's a Unix-based system, that is the case. For example, say you're writing something to the console. When you do this, you're actually writing to a file called standard out. Directories are also files. They're basically just files that have a list of all the file names that are technically in that directory. This metaphor even extends to things like printers and networking sockets. Files themselves consist of the data on disk, as well as a bit of metadata that describes the file. This metadata is contained in a structure called an inode. The inode tells the system where to go on disk to find the actual data. It also includes information about who created that file and who has permission to do what to it. Each of these inode structures is accompanied by an inode number. The number is basically a key to an array that shows you how to get to that inode structure. In the directory file I mentioned earlier, there's an inode number that maps to each file name on the system. This separation of the inode and the file is what makes hard and soft links a possibility. When you make a hard link, you're just making another file that points directly to the same inode on the system. A soft link, on the other hand, is a file that contains a path to the original file. It doesn't actually point to the original inode that the other file points to. All right, let's take a little bit closer of a look at some files. First things first, as usual, let's clear our screen. And then let's just make a new folder real quick. We'll call it Files. Then we'll cd into that. And we'll just make one called hi.txt. Now, as we touched on before, if we use ls with the -lh flag, we can get a more detailed look at what this file consists of. So let's go ahead and do that. And now we see a lot more information about this file. First, we have the dash here, and when you see a dash, that means it's a normal file. There's other options, like you can see L if it's a soft link, S if it's a socket, D if it's a directory. And then we'll learn more about the rest of this permission string in the next video, but for now, just know it kind of defines who has privileges over this file. This 1 represents the number of hard links to this file. Then we have the user that created this file, the user group that they're in, and then we have how big this file is. This one is 0 bytes because it's empty. And then next we have the last time this file was updated, which is right now. And then finally, of course, we have the name. So let's go ahead and explore these hard and soft links a little more. First, we'll make a soft link. Like before, we'll do ln and use -s. And then first we say the name of the file, and then we give it the name of the link. We'll say hi sim.txt. And then once we've done that, we'll do clear. And if you happen to watch the configuration video, then you should have a shortcut for ls-lh called ll. So we'll do ll. And now we see that we do have our symlink. And here it shows that it points to hi.txt. Over here on the left side, you see that instead of a dash, we have an L. And this number has not been incremented. In contrast, let's go ahead and make a hard link to the original file. This time you just do ln with no -s. And we'll say hi.txt is the original, and hi2.txt is the hard link. And now if we do ll, we see a bit different of a situation. Here we have hi.txt and hi2.txt. They're both 0 bytes, both created by the same people. As you can see, the number of hard links has been up to 2 here, and then over here, both of these files are still normal files. Finally, if you want to get a slightly different view of what's going on here, you can do ls and then -i. And this actually means that we want to see the inode number of these files. And here we see that the first number, hi.txt, and the second number are exactly the same. You can think of these numbers as indices into an array, or basically addresses like with pointers, and each of these files point to the same place. At the end of the day, they are essentially exactly the same file. Whereas with this last symlink, we see that it is a completely different file, pointing to a different location on disk.